So example 1 says, Princeton Survey Research reports a survey of 1,917 cell phone users in the US conducted in May of 2010, asking, on an average day, about how many phone calls do you make and receive on your cell phone? So we want to know what is the sample in the study. So the sample is going to be the people who they actually ask. So based on the report of the survey, they asked 1,917 cell phone users in the US. So you want to be as specific as possible. So our sample is going to be 1,917 cell phone users in the US. Then we want to know what is the population of interest. So we want to know who are they trying to learn about. And generally, if they take a good sample, who they're trying to learn about, it's just the overall bigger group that the sample represents. So as long as they take a good random sample, which we can assume the Princeton Survey Research would take an actual random sample, then we can say that our population of interest is we'll just replace the number with the word all. So it'll be all cell phone users in the US. So that's who they're trying to learn about, and they're using the 1,917 of them to learn about kind of this bigger, larger group. Then we want to know, is the variable in the study categorical or quantitative? So again, these are our who, and then the variable is our what. What are they recording about these 1,917 cell phone users? So they want to know, on an average day, how many phone calls do you make and receive? So that's going to be our variable of interest, is how many cell phone calls they make. And receive. So you'd answer that with a number. So since we answered with a number, it's going to be a quantitative variable. Example 2 says, over 30,000 people participated in an online poll on CNN.com conducted in April 2012 asking, have you ever driven with a pet in your lap? We see that 34% of the participants answered yes and 66% answered no. So we know what is our sample. So again, it's who they're actually asking. So they're asking 30,000 people who participated in the poll on CNN.com. So B wants to know, what is the variable of the study, and is it quantitative or categorical? So again, we want to know, what are we asking them? And they're asking them, have they ever driven with a pet on their lap? So we're going to ask if the person has driven with a pet on the lap. So if you were asked that question, you'd either answer with a yes or a no. Since we're answering with a word, that's going to make it a categorical variable. So can we conclude that 34% of all drivers have driven with a pet in their lap? So there's two important things to remember. One is that even if we have a good sample, our sample statistic isn't going to be exactly the same as the overall population. Hopefully they're pretty close to one another. But because we have a sample and we're not asking the entire population, that we can't say that 34% of all drivers have. So if it's a random sample, it should be hopefully somewhat close to 34%. But we don't know what the actual percentage is for all drivers in our population. So D says, explain why it's not appropriate to generalize the results to all drivers, or even all drivers who visit CNN.com. We want to know, what is the problem with this method of data collection? So they conducted an online poll and just asked people to, or just people who visited would be the people who would eye it, and those would be the people who would fill out their online poll. So this is going to be kind of what we call a volunteer survey. So it's just people who happen to see the survey, those are the people who are going to fill it out. And so generally, people with pets are more likely to fill out a survey about pets. So people who have pets are more likely to drive with a pet in their lap. So that's going to kind of make it bigger. And generally, maybe people who have driven with a pet in their lap are more likely to participate in the poll to begin with. Or maybe people who have driven with a pet in their lap are less likely to willingly participate in the poll. So we don't know if it's going to be higher than it should be or lower than it should be. Because it's not a random sample, that means that we can't generalize to the population. And it's not even a random sample of people who visit CNN.com. It's just people who felt like they want to participate in the poll. So how might we select a sample of people that would give us results that we can generalize to a broader population? So what we could do is we could just maybe try to eye people who are driving and see if they have a pet in their lap. Or maybe we could go to the DMV at random times in the year and ask people there if they've driven with a pet in their lap. But in general, if our population is all drivers, and trying to get a random sample of all drivers would be pretty difficult. Maybe if we worked for the federal government or for the DMV, we have a list of everyone who drives, and maybe we could send out either an email or a letter to all of them and ask them if they've driven with a pet in their lap. But that requires kind of a list beforehand, and then maybe even if we do that, most of them probably won't respond to the survey. So it can actually be really difficult to try to get these random samples, and sometimes these flawed and biased samples are maybe the best thing that we can get. So example 3 says, you wish to estimate the number of hours a week students at universities spend studying. For each sampling method below, indicate whether the results are likely to be representative of the entire student body, whether the method is likely to give a biased result. So we want to ask students we find at the library on a Friday night. So if we ask those students, not only are they not a random sample, but those students who spend Friday nights at the library either mean they have an exam coming up, so they probably spent more time studying, or they're probably just more studious in general, so that means it's going to be a biased sample, which means the results of the survey we can't trust to be an accurate overall representation of how many hours students spend studying in general. And in this case, it's probably going to bias the amount upwards, or increase the amount of time students spend studying. So if we ask students who are at a party on a Tuesday night, so again, it's not a random sample of all students. So it's going to be a biased sample. So we can't trust the results, again, to be an accurate representation of all students in the time they spend studying. So in this case, it probably underestimate the amount of time students spend studying. C says, ask a random sample of students eating at the dining hall at 5 tonight. So this one does include a random sample of students, so that's good. But it's asking students at the dining hall at 5 p.m. tonight. So the problem with that is that students eating at the dining hall are more likely to be first years and sophomores. Students who live on campus. So it's kind of skewing the results to the first couple of years. So generally your first couple of years, students tend to take more classes, so maybe they spend more time studying than people who are in their further along, juniors and seniors. Or maybe they spend less time studying because they're not really working on the classes that their major is focusing on. So it's hard to tell, but because it's not a random sample of all students, it's only a random sample of students who eat at that particular dining hall at that time at night. It's not a random sample of all students. So it's going to be biased. D says, ask students in organic chemistry. So from what I understand, organic chemistry is kind of a weed out class, meaning it's going to be difficult. So students taking organic chemistry probably spend more time studying than students not taking organic chemistry for that class. So again, it's probably going to bias the results upwards, where we're going to overestimate the amount of time students spend studying. So not a random sample. We ask all the students on one of the school's athletic teams. So they're asking this time a population, so we're asking all students on an athletic team. But again, it's not going to be a random sample of all students, so we can't trust the result. F says to send an email out to all students and use all the responses that we get. So this is kind of what we call a shotgun style of trying to get responses. So you just send it out to everyone and see just who replies. And the result is that the people who respond are going to be different than the students who don't respond. So maybe there's differences in that the students who spend a lot of time studying are just going to ignore the email. There's students who don't spend a lot of time studying, probably don't care about an email asking them how much time they spend studying, so they'll probably also won't respond. So we'll just get students in the middle, and since it's not going to be a random sample, we can't trust the results. So this is what we call non-response bias, because the people who don't respond bias the results in a certain direction. And G says, ask friends that you know, trying to get a reasonably representative group. So the issue is that asking friends, especially in college, is those students who are probably similar to you, probably have the same major, taking similar classes, or even the same class. So even if you're trying to get a representative group of your friends, it's probably not going to be a representative group of the overall student population. So it may be better than these other methods, but it's still not going to be a random sample, so we can't trust the results. So sometimes, even if we get a random sample, how we word the question can affect how people respond. So how a question is worded can have a dramatic impact on the result. So these two questions appear to be asking the same thing. Do you think the US should allow speeches against democracy? And do you think the US should not forbid speeches against the democracy? However, 21% said such speeches should be allowed, while almost double that said such speeches should not be forbidden. So why do we think the results are going to be so different? So wording these questions are a really important aspect on how people are going to respond. And so if you ask someone to forbid something, then that means generally that they're not going to be that people don't like being told that they can't do something. So that means they're going to be more likely to do it. So how you frame the question can often have a big impact on how people respond, whether you ask the question in a positive light or whether you ask the question more in a negative light. So there's actually a lot of people that spend a lot of time and get paid a fair amount of money writing these questions and surveys to try to give a least biased and a most accurate result from the people who they're asking.